Hello and welcome to the AICE Chemistry Lecture Series. Today we're going to go over Chapter 7, Section 4, which is going to focus on redox and the oxidation numbers. So what we're going to look at here in this very short section is how to put the two things we have talked about together. How to use oxidation numbers and the assigning of oxidation numbers to look at a redox reaction as a whole, and essentially be able to tell whether different elements get oxidized or reduced in that redox reaction. So let's get started. Redox and oxidation numbers are going to be related in the sense that we are going to use oxidation numbers in order to see which elements in a redox reaction are oxidized and reduced. Oxidation numbers are very straightforward, and they're called oxidation numbers for a reason. If the oxidation number increases for an element from the reactants to the products in a reaction, then that element is being oxidized, meaning that that element is losing electrons. On the other hand, if the oxidation number for an element decreases from the reactants to the products in a redox reaction, then we can say that that element is being reduced, or the fact that that element is gaining electrons. If neither of these are true, obviously, then the element is neither getting reduced nor oxidized. In redox reactions like the one we have here, one element is going to be reduced and the other element is, another element is going to be oxidized. That does not mean that there's only two elements. For example, in this reaction, there's tin, hydrogen, nitrogen, and oxygen. There are 4 elements in total. Only one of these 4 elements is going to get oxidized. Only one of these elements will get reduced, and the other 2 simply don't undergo either. So essentially, whenever we have a redox reaction, we will have one element whose oxidation number goes up from the reactants to the products, and that one, the one that increases in oxidation number, is being oxidized. One element which is going down in oxidation number decreases, which will be the one that's getting reduced, and the rest of the elements will have the exact same oxidation number in the reactants as the products. So if we look at this, for example, tin has an oxidation number of 0 because it's an element by itself. Oxygen has an oxidation number of -2 because oxygens usually do. Hydrogen is +1 because it's not a metal hydride. So there's a bit of a review from the oxidation numbers in the previous section. And then there's nitrogen because the oxygens are -2 and there are 3 of them, so that's -6 in total. +1 is -5 and they have to add up to 0, then the nitrogen has to be +5. So that's the oxidation numbers for every element in this reactant. If we go over to the products, the oxidation number of the oxygen here is still -2, because this is neither a peroxide nor F2O. The oxidation number of the tin then has to be +4, because since there are -2 for the oxygens times 2 oxygen total, that's -4, and it has to be cancelled out by that +4. In the NO2, the oxygens are -2, like the oxygens usually are, and because there are 2 of them, then the nitrogen has to be +4. And then finally for the water, again, the oxygens are -2, which means the hydrogens, which is usually the rule, are going to be +1. If we look at these oxidation numbers, we can see that the hydrogen's oxidation number remains the same. Hydrogen is +1 in the reactants, +1 in the products. When we look at the oxygen, we also have the oxygen staying the same. Oxygen is -2 in the reactants, and it is -2 every time it appears in the products. So -2 here, -2 here, -2 here. But if we look at tin, tin's oxidation number is 0 in the reactants and +4 in the products, meaning that tin's oxidation number has increased. It has gone up from the reactants to the products, meaning that in this redox reaction, tin is the element that is getting oxidized. It undergoes oxidation, meaning that this tin is going to lose an electron. On the other hand, if we look at the oxidation number of nitrogen, which is +5, that +5 oxidation number for nitrogen changes to +4 in the product side. So it goes from being +5 in the nitric acid to +4 in the nitrogen dioxide in the products. Because the oxidation number of nitrogen is going down, it's decreasing, we know that nitrogen is getting reduced in this reaction. So this is how we use oxidation numbers in order to tell which particular elements in an oxidation reduction reaction or redox reaction are getting oxidized and which ones are getting reduced, and which ones are staying the same, meaning that they're undergoing neither process. So tin is getting oxidized, meaning it's losing electrons, and those electrons are going to be transferred to the nitrogen, which is getting reduced because the oxidation number goes down. That's pretty much it. That's the gist of how we use oxidation numbers to tell which process each element is undergoing. But for now, that's it for this video, and I'll see you in the next one.